I'm trying some new settings on the stream, so hopefully the quality is a bit better now. But we'll see. We will see. And we're gonna follow up on what we did last time, which was trying to train some stuff using Hugging Face. Let me try and get the chat. All right, cool. Let me know if there's anyone here in the chat. I thought this was pretty funny, by the way. If oh, that was loud. Like, I'm using a green screen to get this like so you can see me like this, and I'm drinking a green smoothie, and it looks like this. I'm drinking. Yeah, just thought it was funny. Please use VS Code. Any particular reason? All right, let's see what we did last time. So last time, the goal, we even wrote this up, implement full training from data loading to model training evaluation using Hugging Face. And then we were stuck on the fly data loading. And I think we skip this for now, to be honest. Let's just cache it the way that they want it to be. And then after we get that working, what did we say? We want to go deeper in every step. So we want to download the data set, load it as a custom data set, so we know how to do that. Compare custom Hugging Face data set. Yeah. Yeah, I'll do that next time. You'll just see like my head pop out. Yeah, we can do that. I have a lot of things planned or like that I want to do. Kind of just time restriction right now. Okay, let's see. So we have, what did we do? All of this was just to learn the model and stuff. I don't think we need to do this. Let's just run this. Hello, welcome to the stream. By the way, I'm using a little bit higher quality on the stream now, and it might be higher delay. I'm not sure. Let me know when you hear this, and we'll see like how long, what the time it is. So that was like 15 sec. All right. That's not too bad. That's not too bad. That's 30 seconds. And I think the stream is 4K now. So you should be able to see everything pretty crisp. Let me know if the quality is good. By the way, I haven't tried these settings before, so hopefully it works well. All right, so let's just get into it then. I wanted to, we can skip these things. I think we import it and then yeah, so I think this is what we wanted to do here probably, and train it. What we did, where is it? This code is messy. Yeah, okay, it's here. So we wanted to do the data loading here, and we did this yielding thing. But let's just change it to what we did before, because I don't know, this So like the default way that Hugging Face loads the data is that they cache it, which is, I mean, it's good, I think, but I don't want to do it that way because it's gonna pre-process the entire. Let me lower this a little bit. Like it's gonna load, it's gonna cache everything, and let's say you have like a 1 terabyte data set size. It's gonna cache it, and it's gonna be a very large file. And also sometimes you just want it to be fast, so like it might take 1 hour for it to actually just be able to cache the entire thing, which is not ideal. I don't know, like they should have some documentation on this. Yeah, so we have a data set from a generator. This approach supports loading data larger than available memory. I feel like this is the only way to do it because it's not going to be general otherwise. So let's just use it the default way. Let's do pre-process examples or pre-process examples. Why don't you use Google Colab? You wouldn't worry about cached files. Well, I don't think that it would still do the same thing, right? So it would still try to cache it, and it would just cache it on the Colab instead. And also Colab is not as fast as sort of a local VM. But Colab works in like for basic stuff, I think. But I don't know if I would train something large on Colab. So this is like the default way how you load things, right? Like if you do this, you do a pre-process function, you run it through each example, you do a summary. This is not correct. I think this should be highlights, and this should be article in examples. this might not be correct. I actually think this is wrong. We go through each of the inputs and the targets. We create those. Yeah, on my machine I have two 3090s, so I can train like moderate stuff. But obviously for larger things, you would need to rent a cluster. But I haven't really encountered situations where I've needed those types of clusters right now. Yeah. NVIDIA 3090. What's wrong here? Doesn't print it. Let's just do print raw data sets of 0. Does this work? Train of 0. All right, so we have article. So if we send in a batch, we go through. This, I think, and then we have highlights or summaries, I guess. Highlights. After we have those, gonna want to do this. And then with tokenizer dot as target tokenizer. Yeah, I think this is how you do it. Hopefully that works. So pre-processed map. Okay, cool. And we can remove this. Nope. Must be integers. It's kind of annoying that it doesn't print, so I can't see actually what the input is here. Lazy batch. Okay. Oh, okay. Yeah, that's not what I want. All right, it's too large. Okay, so if we do, okay, so if we do then for in examples of article, and we do example like this, maybe that works. We got this working yesterday. I should just look at the code then. Tokenizer is not defined. Okay, so now basically, right, we are pre-processing the examples. And the problem, or what I sort of don't like, is that it runs through, right? It runs through the entire data set right now, and it caches it. So, this is quite a small data set, but if you do a really large data set here, it's going to take a long time, and then it's going to cache all the files. That's specific to the way you pre-process the examples here. That's why I kind of want this instead, where you have a generator. But all the examples they show here is kind of that way. So all right, but after we've done this, so I'll show you, after we rerun it like this time, it's going to be cached. So that's nice at least. And then we are going to try to train it. So now if we sort of rerun it, it's gonna give us it directly, I think. No, it's gonna, okay. Huh. Okay, that's a bit surprising, but I guess we can do num processes. I thought it would at least save it, but I guess it didn't. All right, so what are we doing then? We can remove this thing because we're not gonna use this right now, but we are initializing the data set, and the data set is like a text article, and then we have a summary of that article, and we're initializing the model. We're initializing so tokenizer model with auto tokenizer auto model for sequence to sequence language model, because we're gonna do T5 is an encoder decoder architecture. So then we pre-process the examples by tokenizing it, and we are sort of outputting a dictionary here with labels equals to input IDs of model targets. And when that's done, we are, wait, we're doing it again. Okay, this is wrong. Let's remove this, or we can remove it over here maybe instead. So we just got this. And probably we don't need this either, because we're doing it over here anyways. Okay, so we'll just load the data set. We don't need to load it here. All right, so here we're loading the model. We define a collator, and we have some training arguments, and we do a trainer, and that's it. So we'll see if this works. What we should probably do, we need to have some metric, right, to know that it's actually working. See if it can do it. I don't think it did anything though. Okay, so let's try if this works to train it. Yeah, I think the stream is like automatically saved on YouTube, but I'll probably do more refined videos on whatever we're doing here. So if you're interested in learning Hugging Face, we'll get to that later on. We need to change the number of steps that we evaluate on. It would be nice to see just that it works, first of all. So let us try and add steps. Should be like a step that we evaluate on. No? There's so many arguments here. This is kind of like when I know that it exists. Yeah. So let's do that on 50 steps or something. Mm-hmm. Oh, repeated evaluation steps. We'll do that. I don't even know how Rug score works. Is that true? Okay. Recall calculates the recall of n-grams. Okay. For the specific n-grams, RUG1, RUG2. Okay. Maybe we can look in.
What is the RUG metric? For many NLP tasks, we can use common metrics like accuracy or F1 score. But what do you do when you want to measure something like the quality of a summary from a model like T5? In this video, we'll take a look at a widely used metric for text summarization called RUG. There are actually several variants of RUG, but the basic idea behind all of them is to assign a single numerical score to a summary that tells us how good it is compared to one or more reference summaries. In this example, we have a book review that has been summarized by some model.
Out of memory. Damn. Try to allocate. Okay. Wonder if it's using. We can probably clean our notebook up a little bit because it's pretty messy right now. Or we can just create a new notebook. Fine tuning T5 small CNN daily. Okay. Let's see. We want to take. Oh. I did my undergraduate in mathematics, but it was sort of applied mathematics and a mix of sort of in optimization and stuff like that. And then I'm doing my master's now. I'm doing my thesis now in data science. But I would kind of say that, you know, yeah, I can. How do you do that? I don't use notebook that much. I just thought it would be useful in this scenario, but I have to do this. That seems a little bit unnecessary, maybe. Why? It's not working. Okay. I don't know. Doesn't seem to work. It might be that okay. Is this better? Okay. Yeah, it might not be the best. I don't know. Like I usually don't work that much in notebooks except for like data exploration and stuff, but yeah. All right, what's the blue theme? Like can you what should I set here? I mean, yeah, we can probably just remove it, right? Yeah. It said like some tokenizers has different target than properties, but I don't know. All right, so if we pre-process the data now, and then we are running the model. Whoa, this is not correct. We need to have the latest one. This one. With the RUG. So it's doing metrics.compute, RUG1. Huh. All right. All right, so let's then now hopefully we get it to work, right? So now we can fine tune it. Let us maybe initialize it from scratch so that we know that it's working sort of without, you know, it might be fine tuned on this already. I'm not sure, probably. And how we do that is that we, I guess, remove the from trained here. So we do this. Guess we can keep it and then we can remove it. Oh, I guess you need to do this. Yeah, I think that's how they did it in the example I saw. So we can probably do it that way. I guess the auto model thing is supposed to be from pre-trained. But that's okay. We want to see now how the training works and that our evaluation and stuff works, and then see if it actually improves. And then we'll randomly initialize it and retrain it and see that it works as well. And then want to rewrite code to be more general. So that means data loading should be from disk rather than their load data set. And should be on the fly. What else? Models should be in Lightning code. So trainer, etc. using Lightning. What else do we want? Compute metrics. Fine that we use HuggingFace because I think they are pretty good at that. Oh, an error. So this is odd. Not sure why we get. So it's using 14 megabyte. 14. So this is also a problem. Let's say we reduce the batch size. I mean, per device eval batch size should be, I don't know if it sets something else otherwise because it works during training, right? So here it works fine. And if we look at $20 gigabytes, and it's also using this. Okay, doesn't seem, oh, it does. Crashed again. Huh. Let us reduce the batch size then, I guess. A little bit surprised that it does that. And then we should also do device equals CUDA 0, I guess. Because I only want to use one. Okay. Oh, restarted it? Right. This import, and we'll do it from scratch as well. Huh. And ChatGPT making stuff up. Oh my god. Okay. That feels a little bit weird that I have to do that. All right, whatever. I'll do that then. So this is what I mean, by the way, with the cached, like it does this. So it has created these and just loads them. Now it's still using both GPUs. That's strange. All right. So like the trainer for Hugging Face probably works pretty well, I guess, but whoa, and it's crashing again. What is happening there? In the evaluation? Huh. So why is it taking up so much memory here? Not sure. See, like changing the batch size, you need to rerun it like this. And it's gonna save the cached files again. It's just super. I actually don't know why it's doing that though. Mm-hmm. A bit confused over the it needs to be in the evaluation, right? Because it's training fine. And now it only seems to be using one GPU. So that's good. Yeah, so like training it is super. I mean, it's like 5 gigabytes. But as soon as you take in the evaluation with the compute metrics, then it's no good. So now it's running and then out of memory. Maybe it's important to do like but it's not doing that though. It's not computing any scores here. That would not make a difference, I don't think. Yeah, I'm confused. So the question is, why would it be stacking when we're doing it on the evaluation? Because it should, I guess, automatically. See if ChatGPT has them. No, that's not it. Because it's very low when doing the training, so I'm not sure why it would be that much larger. Yo, Balram. What's up? I think I'm mispronouncing your name every time, but it's fine. I mean, like, even if we do like 1 here, I think we're gonna see that it's gonna it's gonna use a little bit and then it's gonna increase over time. See? Oh, it crashed? No? Huh. It varies so much. This is on batch size 1. There's definitely something wrong. See, it's increasing. And now it's gonna crash. It goes down. Okay, it keeps up. Okay. But yeah, it's definitely too high. I wonder if Oh, and this is on batch size 1. This is strange. And it's gonna take 26 minutes too. And that's way too long. Yeah, Billy. I was like, I knew you said her nickname, but yeah. Yeah, people were complaining. I've never used this team before, but it's nice. I like it. Yeah, we get out of memory. This is confusing stuff. I wonder if it has to do with the metric. But it's not even computing the metric. It's just running through the data set. I know I did something similar when it might have to do with this, the generation max length, right? When evaluation. It could have to do with that. So generation max. It could definitely have to do with that, because if it's not sort of stopping, then 225. It could be this. We'll try it. I guess. It's definitely better. Let's do a restart and run all. It's still too high though for some reason. And that was with batch size 1? No. This is not correct. It's not right. What is going on? So maybe it has to do with that the examples are so varied when doing this. So maybe we do like, you can't read this though. What does it even say here? We're continuing from the last, what we did, and so we're trying to fine tune it now, and we added this metric. So we want to just see that it works using Hugging Face, and then what we're gonna do is we want to rewrite it to be more general, and so data loading should be, sort of from disk on the fly, and then we're gonna rewrite it because I don't like using Hugging Face Trainer and so on. So we're gonna see how we can integrate it instead using Lightning. But I think it's a good start to make it work with Hugging Face before, and then we'll just change it step by step to be more general. So that's the idea. But right now, it's not working because it works when training, but then when we want to evaluate it on the validation data using this RUG metric, the problem is that we get out of memory issues. So I'm trying to figure that out. I'm thinking it has to do with the padding of the examples, so that some examples are really large or something, and then it just doesn't work for that reason. But I don't know. So what I'm thinking is I want to get the shape and see if there are like some articles that are insanely large or something. But yeah, we should be able to print this. Yeah. So if we print this and we get tokenizer of input IDs, I don't like not having the stop thing. Usually on the, if you have the white team, you have a sort of a stop. I guess I can look the shortcut, but okay, so here we go. If we have this, and then we have token indices sequence is longer. Indexing error. Huh. Okay, so if we do, oh right, okay, so if we do exam here, tokenizer of example of input IDs, and then length maybe. Those are super tiny. 224, what? 224. Okay, that's not right. Honestly, I'm gonna change back because I need to have the need to have this thing. What is the shortcut for this? I don't know. I'd like to see like a notebook. See how they did it. Because there might be something wrong in the pre-processing, probably. I mean, there needs to be like a repo. What's up, Anai? So I don't know, it seems like 512 and 128 is good enough. Because that's what he's using here. Padding max length. So this is kind of the exact same as depressed. What? Why? So okay. Well, we'll set 512, 128. Yeah, if I'm sad, it's because I want this to work. It's annoying. Like, this should not be so hard, but for some reason it is. Yeah, exactly. I mean, like, if you see out of memory issues, then how can you not be depressed? You know, it's like either your hardware is shit, you know, or there's something wrong with the code, and in both cases, you're sad. Oh, he sends in batch here. I guess we'll do batch. So what does he do later on? Okay, training data map, and then he does remove columns. Fine, we can do that. That's probably smart. Batch size equals batch size. Oh, we can set the batch size here. 4. Huh. All right, fine. Okay, he does it a little bit differently than we were thinking. Then he's encoded the coder model. We can probably set float 16 too. We're doing pretty much the same thing. Hmm. Okay. So there should not be some huge error that we're doing here. It should not be that, because like what he's doing is pretty much the same thing. But we should probably do something similar to what they're doing. Also, we don't need to take the entire data that way. You know, we can take like small parts. And I'll take the advice from Billy. I will go make a cup of coffee. Oh shit. All right, we got a cup of coffee. Let's try to figure this out. Like this, what I'm doing now is actually not that related to it, a little bit, but I want to learn Hugging Phase anyways. And I thought, you know, I'll make videos. Hopefully, I'll make videos on it if I get like a good understanding of it. But yeah, so I mean, like I've used Hugging Face before, kind of, but always sort of dabbled in it, and I would like to just get a deeper and better understanding and get more comfortable with the library, and that's, you know, pretty much it. Like we didn't really do that much different though, so I don't expect predict width generate, predict width, predict width generate. You know. Oh, okay, but this seemed to make a big difference. Like this is what I'm talking about, okay? I have no idea what's going on. that's that's the problem. Like I have no clue. How is this working? I mean, all I did now is change what? Predict with generate? Is that the difference? We got out of memory issues all the time. It doesn't make sense. It probably makes sense, but yeah. All right, so it's using 5 GB. I mean, this is too large, right? We don't need that. It's taking too long. So let's do what he did, and we will do a train data set here. Pre-process of what? Raw data. How did he do it? So he went here. Like everything that's green gets messed up. Huh. It's not even that green. It's just slightly green. So I really want to like HuggingFace because I know it has potential, but I don't know. It's just everything is so hidden and I don't understand it. So here, train data. Let's see, what did he do? How did he get train data and stuff? Okay, so we have trained. Okay, he does it here. All right, we can do that. So we do train data, data sets load, split train, and then we'll take the validation, val data, and validation. So this is cool that you can do it this way. Take 10% just for quick iterations. Nice. And hopefully this works. We don't need this. So we'll do that. And we'll set batch size. Batch equals true. Batch size equals 8 maybe. Remove this. Yeah, it's like doesn't, I don't understand it. We'll check. I mean, that's how you learn things, right? You figure them out, and we'll try to see if we can do that. Datasets is not defined. Okay. Import datasets. No? Doesn't have a batched key. We just did this though. Oh, we don't need data sets like this. Load data set. Oh, my bad. This is not right. This is like this. And then we will do the mapping. So this will be... Oh, okay. So this is a mistake on my part. We do the remove columns and stuff after, right? So we do this. Batch true, batch size. I don't know exactly what to use for the batch size here, but this is maybe fine. I think probably you can use something larger that's faster because you can interrupt. Okay, nice. That's actually nice. So I can, when that's the case, we can bring back this. Because that's why I wanted to use the white thing. I'm so bad at using Jupyter notebooks. I have never learned the shortcuts. All right. Yeah, this is too slow. I think we can definitely use something larger than this. I don't think. Boom. Nice. Thanks for the shortcut on that. Yeah, what do you guys think? Like, okay, so, oh, Jupyter God. Tell me some like what like is the secret? So, by the way, let's talk about this. So, okay, so I've used VS Code and like just Jupyter inside, and it's nice because you have GitHub Copilot integration and all of that nice stuff. So this is not optimal to work like as a workflow, I would say. But I guess you can integrate it as well. There's probably some way. But what I like to do the most is to have to use Vim. I like that, but it's not very nice for things like this, right? You can't use Python in this way when you're sort of exploring stuff, I would say. Like for training things, when it's actually like you have everything working, it's good. But now we need to load the model and all of that stuff, and we need to like try things out quickly and iterate and so on. And if it takes like 5 minutes to reload the model, then it doesn't make sense to do that. That's when like Jupyter notebooks, that's when I use them. And for like quick exploration, like if you're loading data and it's like 10 gigabyte like Parquet file or whatever, and then you're doing some data, and like you can't reload it every time, obviously. So you need to load it in memory in some way, and that's where Jupyter Notebook is nice. That's how I use it. But let me know sort of what you think. Like, how do you do it? And how do you actually, if you're working only from Jupyter Notebooks, like how do you get, I don't know, how do you make it work in a nice way? All right, cool. Now it's done with this. Let's try and run it. Pre-processed data. No, that's true. So this is train data set, file data set. So here's the problem with why I didn't use VS Code. So I use VS Code, but when you want to SSH into a cluster, or sort of, in my case, the VM, I don't like the fact that I have to reopen everything. There's like 3 times I need to rewrite the password. I get kicked out if I like, I don't know. It just always wants to like, what issues did I actually encountered? So sometimes when training the model in VS Code, it would occasionally like kick me out. And that was a problem because then it stopped training on the virtual machine. So I wanted, if I run something, I want to be able to SSH back into the VS Code and things will still be running on the virtual machine, not on my, but it's sort of, it's dependent that I have the VS Code connection on my local machine to the VM, and that's when it's running. And if it loses the connection, it automatically stops running. That was my experience. So I was like, that's annoying. And that's why I use Tmux instead. Because like if you go to Tmux and you open it, you have everything. It's like it's running on the VM, and the only like everything is local on the VM. And then you're just running, you're just opening that up. And like if you want to restart, you're in this, you go to like this, attach. We're here on the, it has the Jupyter notebook, right? Like we detach, we restart the machine, everything, boom, we're back. And it's like instant, fast. It's not gonna cause any of those issues. That's my experience like with using notebooks and stuff. So, but I'm open, like if there are better workflows. If somebody has used like, I guess there are settings that you can change in VS Code and it will work better. But yeah. Why did I name it like this? Val data and train data. What's up, Mark? Welcome to the stream. We are trying to learn the intricacies of Hugging Face, but so far it's only making us depressed. All right, but this is nice. We're not getting out of memory issues anymore because we have predict with generate, I guess. I think honestly, it's that on the evaluation, it's using like an insane beam search or something. Like it's not using generate like greedy or something. That's what I think. And then with the beam search, like if you have a batch where it's like padded a lot, that's why it varied that much. And also, why do we get this? I have no idea. All right, that's fine. Okay, let's see if it works now. Boom, there we go. Nice. We get validation loss, RUG, recall, precision, F measure. All right, nice. So let's change this now. Let's do to 250 or 500 maybe. And let's increase the batch size here. And let's do II to stop it. And then we will rerun it. Cool. So, you know, now it should hopefully be, we should see an improvement. Yeah. All right, what do we want to do now? I definitely want to change this so that we have a general way of loading, because I don't like this, but Yeah, we might do that later. There are so many like libraries of loading stuff. It's so confusing. You can use torch text, you can use HuggingFace, you can probably use lightning, you can use, there are so many ways, I feel like. Cool. And then how do we get rid of this? Like it's doing this. So let's see if ChatGPT knows. I'm thinking this is with, what is it doing now? Okay. So what I'm thinking is that it's doing some beam search stuff, and that's why it's causing this out of memory stuff. Generate quarks. Fine. Okay, so we get this. Okay, that's a lot different than before. But so like if you, okay, but so if you have a VS Code, right? You set it up on your laptop, you SSH into a cluster, and then you start running some training. And let's say that the internet connection breaks. For me, that causes, yeah, it's probably the configuration, but for me, that caused so that the training on the VM basically stopped. So I had to ensure that the connection was stable, but I wanted things, I wanted to just be able to SSH back into the Jupyter Notebook or whatever I was working from, and it would still be running in the VS Code. That was my issue. And that's why I moved to using Vim, because then I can just attach to Tmux. Everything is running on the VM, and it's like super fast. You can just automatically attach. You can restart. It will still be able to attach and so on. But like most people seem to use VS Code, so yeah. All right, but this seems to be working fine. So let's try and improve this now. We should probably rewrite it to Lightning because it's most likely going to be nicer. Yeah. Yeah, so that's my problem with it, that it's dependent on the connection, because I want to like start a script, running training script. I want to be able to shut my laptop, open it up a couple of hours later, SSH back, it's still running, and you get sort of up to speed. But I can't imagine that there's no configuration for that, but I wasn't able to. All right, but then like this is nice. So we got this working at least, and let's see what it said. Okay, I'm not sure if we trust this. Okay, so oh, what happened here? Let's try and understand this RUG thing because
If
I
we
don't know
compare
how
the
it
generated
works.
summary to some reference human summaries, we can see that the model is actually pretty good and only differs by a word or two. So how can we measure the quality of a generated summary in an automatic way? The approach that Rouge takes is to compare the n-grams of the generated summary to the n-grams of the references. An n-gram is just a fancy way of saying a chunk of n words. So let's start with unigrams, which correspond to the individual words in a sentence. In this example, you can see that 6 of the words in the generated summary are also found in one of the reference summaries, and the Rouge metric that compares unigrams is called Rouge1. Now that we've found our matches, one way to assign a score to the summary is to compute the recall of the unigrams. This means we just count the number of matching words in the generated and reference summaries and normalize the count by dividing by the number of words in the reference.
Oh wait, so you want this to be large, I guess? Okay, yeah. So you want this to increase. Okay, so this is actually an improvement then. So is 1 the
In this
highest?
example, we found 6 matching words and our reference has 6 words. So our unigram recall is perfect. This
Cool.
means that all of the words in the reference summary have been produced in the generated one. Now, perfect recall sounds great, but imagine if our generated summary had been something like, I really loved reading The Hunger Games. This would also have perfect recall, but is arguably a worse summary since it is verbose. To deal with these scenarios, we can also compute precision, which in the Rouge context measures how much of the generated summary was relevant. In practice, both precision and recall are usually computed, and then the F1 score is reported. Now, we can change the granularity of the comparison by comparing bigrams instead of unigrams. With bigrams, we chunk the sentence into pairs of consecutive words and then count how many pairs in the generated summary are present in the reference one. This gives us Rouge 2 precision and recall, which as we can see is lower than the Rouge 1 scores from earlier.
Oh, okay. So RUG 2, it takes the matching 2 words and then it compares if those two exist. All right. So I guess okay.
Now, if the summaries are long,
What is the sort of default evaluation then? If we go to docs here or models here and we go to summarization, BART, RUG1, RUG2, RUG-L. Okay. Predict would generate to predict. Cool.
the Rouge 2 scores will generally be small because there are fewer bigrams
You can use VS Code Remote as a extension.
to match.
Yeah, okay. I'll look into that because then it's,
And this is also true
it's nice.
for abstractor summarization. So both Rouge 1 and Rouge 2 scores are usually reported.
I think I was using it though. Maybe I didn't. I think so.
The last Rouge variant we'll discuss is Rouge L. Rouge L doesn't compare n-grams, but instead treats each summary as a sequence of words and then looks for the longest common subsequence, or LCS. A subsequence is a sequence that appears in the same relative order, but not necessarily contiguous. So in this example, I loved reading The Hunger Games is the longest common subsequence between the two summaries. And the main advantage of Rouge L over Rouge 1 or Rouge 2 is that it doesn't depend on consecutive n-gram matches, and so it tends to capture sentence structure much more accurately. Now, to compute Rouge scores in the datasets library is very simple. You just use the load metric function, provide your model summaries along with the references, and you're good to go. The output from the calculation contains a lot of information. The first thing we can see is that the confidence intervals of each root score are provided in the low, mid, and high fields. This is really useful if you want to know the spread of your root scores when comparing two or more models. The second thing to notice is that we have 4 types of root score. We've already seen Rouge 1, Rouge 2, and Rouge L sum. Well, the sum in Rouge L sum refers to the fact that this metric is computed over a whole summary, while Rouge L is computed as the average over individual sentences.
This was a good video. So that's nice. Let's create a new notebook and let's try and make it with Lightning and how we can integrate HuggingFace and Lightning, because I think that's more general. But before we do that, yo, Ariane, what's up? But before we do that, let's go to the, we'll keep this because this is a good one. Also nice that they have this. So let's see if we can take a look at this. Blip 2. All right. They seem to have like a pretty nice blog here. Parameter efficient fine tuning. This could be interesting. Really? You can fine tune a 3 billion parameter on a 3080? That's pretty insane. Stable diffusion, dream boot training. I think we're going to do that in a stream like sometime soon, because I think it would be really cool. It's so quiet. Let me bring up some music. Oh, this is actually nice. So they even have a notebook here? How to fine tune it? I guess. Nice. Okay. Let's bring this up again. So let's do file, new notebook. And let's do conversion to, how do I change the name? Rename. Fine tuning. Convert, or what do we call this? Fine tune. Okay. So now's the question, how do we convert this actually? I guess we will, I mean, we can still load the data this way because we have this, right? And we'll convert it to a data loader. And then we can just create it in the trainer. And then we'll slowly change it. And the metric we can definitely use. But I wonder if we have... I don't think Lightning has those metrics. So we probably want to use like HuggingFace metrics here. And just convert this to a... So trainer, it will be pretty easy, I think, because the model outputs the loss. So that seems pretty okay to me. The only question is here, like, how do you do this compute metrics and stuff? Not sure about that. I mean, like, the idea is also if we go to this, yeah, done somewhere, we should be able to input like any article, and then we should be able to get the summarized version of that news article. I wonder if you can do like... Can we do this, do you think? If we do just put everything in a single one, and we do this and this. And I was thinking like we basically ask ChatGPT. Do you think it's able to do it? Yeah, we'll see. I mean, it probably will, right? But oh, we don't need those. Don't need that many. My data module, batch size, prepare data, download, load data set. This is fine. Setup, load data set again. Oh, okay. I mean, it makes sense. Like you download it here and then you have it. You do a mapping. This is fine. This is good. Pre-process. We have this here. It might be that it doesn't have that long context. We'll see. I mean, this is a lot of code. This is correct. This is what I was going to do. That's nice. And then it should create a Lightning module. Yeah, it stopped. No, it continued. Okay. Tokenizer. See, it outputs the loss directly. So that's nice. It will just run the forward. Did it stop? Okay, it actually stopped now. Yeah, you were right. It stopped. Yeah, it doesn't have that long context because it's a lot of code, right? So I think we can start with this though because it was actually pretty good. Yeah, I agree. It sucks. We can remove this and token classification, masked LM. Let's see. What did we want to do here? My lightning module. Set all of this up. Self.model. It runs the forward here. No. Okay, self.model, right? It will output the loss. Yeah, that's. I didn't even see that you said ask for the remaining code. I mean, the only problem is I think it needed the context. All right, so we have loss logits. Self.log, it returns the loss and the logits. Validation step. Cool. I wonder how it will integrate the compute metrics thing. Where do we do that? I mean, we have to do it here somewhere, I think. Um, the the one I'm working on now is a recommender system project. So it doesn't have that much to do with HuggingFace, but it has some aspects that I'm. Oh, what happened now? How do I convert this back? Oh, what happened? Can we go back? No. Now it's like actually a flash grenade. Like if you actually accidentally remove this in some way. What is it that we want now? Like we have the data module, right? And we are creating a data loader. We're pre-processing it. and we're mapping it. We need to, however, we're doing a training step. Uh, 3D object detection, probably, but I have a lot of other stuff that I'm wanting to work on now, so it will probably be in the future. Kind of like have to be for some type of project that I'm doing. I'm not sure how we integrate the, like the difference here is, right, we're not integrating this. Right, yeah, that's how we do it. Yeah, so we right, we just, yeah, that should be right, that should work. We just compute it at the end of the epoch. Hopefully it doesn't stop in the middle now. I don't know how long context it has. This is, by the way, like the chat GPT plus version that's supposed to be faster, but I don't feel like that it's that much faster. Is this right? So validation epoch end outputs, decoded preds, we do batch the code of large, okay. That should probably be correct, honestly. Damn, I'm impressed by by ChatGPT. Can you find a response in the network tab or is it encrypted? Can you find a response? What do you mean response? Response in the network tab? I'm confused. Okay, now let's copy this. Let's bring it over here. Let's take the trainer as well. Cool. And oh, that's not good. We should not copy the entire thing. Copy paste code because that's what we do. Oh, you mean like hook up ChatGPT to a Chrome dev? I'm not sure what. So what is it that you want to do? Like you want to get the API or something, so you can run it. Oh, and then you can get the API. You mean? Okay, so we have that. Now let's see. Oh. I already have. Like, I don't know. I think it's fine, to be honest. Like, I don't know. Like, I guess you don't want to become too dependent, but yeah, I don't know. It's a tricky thing. Okay. If we do this, I don't know if it's gonna be able to run automatically. Probably not. But I do. Okay. But wait, it's not doing the right thing. We have a data module. Oh, but it didn't know obviously that we had the data module. Right, we will also set this torch set whatever. Tokenizer is not defined. Where do we do that? Tokenizer here. Yeah, I mean obviously we need to define that. Self.tokenizer, self.tokenizer. I'm surprised we did not do that. Oh, it's here. You need to have it in both, I guess, or you can set it just outside. Maybe that's the best. So you take it back and you do tokenizer like this. Yeah, that's probably the best. So we'll define it here. Self model name, just model name. Oh. Nice. Okay, so it's working now. That's good. For your recommendation engine, it's going to be only the model. So, the model is gonna be like for now it's just focused on the cold star problem, but it will probably be some hybrid recommender system once data is collected. So content and collaborative based. Where do we set the batch size for training? Okay. Is this slower than before, right? Or no? I guess not. Is it because we set the number of training steps 5,000 here? Why is it 7? Oh, that's the entire... I'm confused. So we set num training steps equals 5,000. What? My lightning module, we said num training steps. Where is this even used? It's not used anywhere, right? Oh my god, it's not used anywhere. Oh my god, come on. Maybe Twitter for 2 minutes. It is faster? That's cool. I don't know. I mean, we can run it side by side and compare. But I do like this more. I feel more at home with Lightning. All right, Twitter. What's going on, Twitter? Microsoft research released BioGPT, and this is pretty goddamn awesome to me. If you've seen this, like BioGPT was here in September last year. This was 345, which is just above human level performance on PubMed QA. And then, boom, like here you have like 175 billion. You have like huge models, 540 billion, and then they fine-tune this BioGPT. Yeah, I mean, like we do. How do we do that? Import warnings, import warnings, and then warnings dot set filter something, right? Messi. Okay. Filter warnings, yeah. My list would be different. In what order did you learn your languages? And then they have like 11 languages here. Mine would be 1, Python. And that's it. Nothing else. All right, I'll add English as well if that's a language. Oh wait, okay, I guess mine would be Swedish, English, and then Python. Oh, God. Hey, look at this. Ben Shapiro, highest on the ladder. Oh, God. Do you think like Bing search is better than? I haven't tried it. Is Bing search better than ChatGPT? There's a delay. I don't know what you're laughing at now. Oh yeah, the Hindi, English, Python, and C++. All right, well you have C++ on the list. That's respectable. I mean, I have done a little bit C++, but I would not say that I can code C++. But probably with the help of ChatGPT, I can. This is pretty insane. GPT implemented in 60 lines of code And Andre is sad. Oh, it's only code for inference. Huh. What a time to be alive. This is, oh, you have to have a trial. All right, let's go back. So, I mean, this is nice. That it, oh, what happened? List has no attribute. Okay, let's go through this. Do you study any mathematics or only machine learning? I studied mathematics during my undergrad, but to be honest, like now I don't do everything I do is pretty much like application dependent. So depending on what I want to do, I learn specifically for that, and then it might involve some math, but it's pretty specific. I feel like in general, like you should learn things based on what you need to know. I think you can waste a lot of time doing stuff that you won't even remember later on. Like I don't remember how I did like triple integrals in spherical coordinates, you know, but and how the method was for doing that. I can probably relearn it pretty quickly though. But was there any usefulness of learning how to do triple integrals? I don't know how much, like maybe. So everything I do is pretty specific. If I want to learn something for a project, I learn it specifically, and then the idea is to kind of use it, you know? All right, I'll be right back. And then we'll clean up this code and try to make it work a little bit better. But I like that we have it in Lightning code now, and how we'll compare it and see if it's faster or slower. The only thing we will do also is fix this data lightning module here. We want to replace this so that we load it sort of reloaded with custom data class, so we have a general, and that would be pretty cool. And then we'll do a predict function and so on, so that we can try it on some actual news and we can see if it works. All right, I'll be right back though. All right, we're back. So let's see if we can split this code a little bit. And we'll do this part on sort of a single import here. Okay, so what's going on here? In the Lightning module, right, we initialize it. Model name, learning rate, indicate batch size. I think we need all of those probably. This is the Lightning module. Okay, let's go up. So prepare data, we have batch size, we download it, we set it up by mapping. We set the batch size here. This should probably be larger though, because yeah, it doesn't matter though. It's going to be cached at this point. So we pre-process it. Data loader here. Cool. And then we create the Lightning module, load metric rook, forward, we output the loss. Now I think in the, all right, so we do training loss here, on epoch, on step, return loss and logit. Validation step, we do the same thing. YOLO V8 code. I mean, I think there are a lot of people that's already kind of showed you how to fine tune it and stuff, but I feel like it's nice if we would do some project that involve object detection, then I would probably use it. But I'm a bit skeptical of like which version to use. Like it's a mess. The YOLO V8, like V8, V6, V5, and or I guess V6 doesn't. V7 doesn't exist, right? But why did they skip V7? I don't know. Validation epoch end. So we go through this and we get metric compute, rook, and then we log them. That should be pretty correct, I feel like. So what error did we get? If we do this, we run, we don't send this in. Max steps, model.num training steps. So we can do 1000 here. Or actually num epochs. We'll do 10. And it will do it at the end. But what we should do first is, oh, num epochs. I need to update the code and push it to let's see if we push this to our GitHub. Oh, you want like how? Yeah, we can probably do like paper or something. But I'm kind of generally lately I've been more interested in just sort of making stuff work well. Like I want to get into more dev, like be able to deploy stuff. Oh, I shouldn't have removed that though. Fuck. Alright, that's fine. VAE. What else have we done in Lightning? This is what I want. I wonder if we can do git add all on this, or if it will mess something up. Let's see. I have no idea how this even got here. D7. It's taking too long. I think probably it's in PyTorch Lightning. Like it's two large files here probably. Because I did not clean this up, so. So messy, but we don't need that. Finished. I don't think I need it. Maybe we can do finished. All right, so now we should probably have better. I hope. Can't imagine what's taking a lot of space now. Okay. Cool. All right, that was I need to update this as well, like the machine learning collection to get with lightning code here. But now if you go to PyTorch, PyTorch Lightning, and this should be better formatted maybe. And then we go to, I don't know, the last one maybe. All right, max epochs. That's how you did it. All this for max epochs. Okay. Let's do that as well. Torch.set float 32. Okay, so that's one epoch and it will do evaluate on the end. We can probably reorganize this now to have like an actual Python file. So but that's nice. And maybe we should do, I don't like that it's like this, by the way. I would like to, I don't know why it's making a new, all the time, a new line. And it should probably not be deterministic here. Logger false. Can take that away. You know, I think we can probably remove the on step thing because I think it's gonna be, that will remove this part. On step is probably fine, but not in Jupyter Notebook, as you can tell. All right, and it's also wrong. Sanity checking data loader. This is why we should do the sanity check before, because now list object has no attribute size. What are we running here? Output self.model. So I guess it is here probably. We're running the batch input IDs. Loss, we're getting that. Cannot see what the difference is between those. It's still doing this? What? Don't do that. Or do I change it on the... On epoch, on step false. On step false. Does this help? No? Okay. And it's still not. Let's try and rerun it. Oh, and we need to do this here as well. Okay, I thought I set the tokenizer, but I guess I removed it somehow. Yeah, I did. All right. So let's go back here. All right. Okay, now it works. That's nice. Don't know what the difference is, but no. Okay. So it ran through the thing, but then I guess in the... This is so annoying. I can't have that. It's still like that. Ah. All right, whatever. Oh, no, I actually removed it. Oh, got them. I guess it's in the validation epoch end, probably. We're getting the outputs, going through them, we're getting the logits and the labels. We don't have labels though. Yeah, that's probably why. We need to set labels here if we want them. I think that's why it doesn't work. All right, we did do some progress today though, which was nice. So we know how to fine tune it now. And we converted it to Lightning, and now we just gotta make it a little bit more general, and then we can compare it. And see how it is. And that is pretty nice. So what's wrong here? Yeah, I do think it has to do with this, because if we do not have this, I imagine it's gonna work fine. We'll see though. And now it's not working again. Okay, it's still... Okay, so it doesn't actually have to do with that. Okay, so there's nothing wrong with that. I mean, these yellow stuff is so annoying to I can't even read it, you know? Why is the coloring like that? Hey, is it a quick question? Is it standard to implement the training validation step function in a model class? I usually just implement the entire train in a global function and call the function that reflects number of epochs. I mean, that's fine. If you, I mean, you're probably doing it in bare bones PyTorch, right? Here we're doing it in Lightning, and they sort of expect you to do it in that type of format with a training step, validation step. So that's probably just why. Okay, so it's having here on the validation step, it's having difficulty computing the actual loss here. And I have no idea why, because this is, I can't have it like this. I'm gonna change it back to not use this. Still with this mono chi thing, which is also annoying. All right, I'll figure this out in the next, or off stream maybe, or in the next stream. I can't imagine that it's something that big, because we're doing the exact same thing here, right? I can't see exactly what the difference is though. I mean, we're pre-processing stuff pretty much the exact same way. I really can't see what the big difference is. And it's not super clear from the error. Like, we're doing training fit here, call fit and handle. I can't read this. This is so straining. Run train, run sanity, advance, evaluation step. Yeah, I'll probably do that. If I'm gonna use notebooks, I'll use that in the future. because this is annoying. But I think that's it for this stream. We got pretty far, I would say. It was pretty productive. So like recap what we did. Fine-tuned T5 small on what was it, daily CNN, summarize news articles using HuggingFace trainer, data loading, converted to Lightning code, and sort of what we want to do. Right, what we want to do next is, I mean, make it work with the evaluation. Something's wrong now. Don't think it's big issue, but yeah. And then, what else do we want to do? Yeah, maybe just clean up the code a bit. And then we also want to, next to that, we want to, after we clean up the code, we want to compare it. HuggingFace. There was something else I wanted to do that was a little bit, add predict function. Oh yeah, modify data loading, so it's from scratch or a more general way of doing it. That's probably the next steps. All right. We'll continue from this in the next stream probably, or if I do it off stream, not sure. But thanks for the ones that were joining, and happy